All right, my stats students, here we go. Last section of chapter 228, fitting models to curved relationships. So, through your algebra days, you have heard of these type of curved relationships, again, meaning non-linear. The two we're going to talk about here are quadratic and exponential. And again, I think you are very familiar with them. So we're going to use some technology to construct these models, and then again, use residual plots to see if the model is appropriate or not, just like we did in 2.7. All right, so this is a quadratic model. So again, quadratic. Remember that the graph is a parabola or a U shape. Here is the form that we're going to use. So y hat equals ax squared plus bx plus c. Again, I want to show you that the ax squared comes first. So ax squared first. You'll see that in our stats applet, they actually put the ax squared last. They do this in reverse order. I want to make sure you put the ax squared first. So be aware of that. So here's an example of age of a quarterback and passing yards. So this is for QBs in the NFL. So typically with a quadratic model or a parabolic model, you kind of start low, you go high at some point, and then you come back down low. Or you could be a U like this too, right? You could start high, go low, come back up, something like that. So think about in the NFL, right? Usually rookie quarterbacks, they don't do very well. Then as you get midway through your career, you start doing better. And then as you get older, it's time to hang up the shoes, right? Because you just can't move as well, can't throw as far, wear and tear. So this is a good parabolic or quadratic model to model age versus passing yards of a quarterback. All right, cool. Oh, sorry about that. Let me erase those. So here's our first example. It says, how does speed affect braking distance? How is the braking distance for a motorcycle related to the speed the motorcycle was going when the brake was applied? The table shows the speed in miles per hour and the distance needed to come to a complete stop when the brake was applied in feet. A, calculate the quadratic model for these data using speed as the explanatory variable. So speed is your explanatory, or your x, that means distance is your response, or your y, right? Okay, so I'm going to take a picture of this data, and we're going to enter it into our 2 quantitative stats applet. Okay, so let me get out of this. Let me go to stats applets. Here we go. I'm going to open it up here. We're going to go to 2 quantitative stats applets, so statistical applets, 2 quantitative. So my explanatory is speed. Notice that I want you to, you didn't read part B yet, but part B says, sketch the scatter plot. So you want to put in the variable names and their units. And again, just go in order. So 1.42, I'm sorry, what am I doing? 6, 9, 19, 30. And then the next column for speed is 32, 40, and 48. So that's the speed you were traveling before you decided to brake. And then distance it took for you to stop, feet. So 1.42. I keep putting 1.41. 4.92, 18.00, 44.75, 52.08, 84.00, and 110.33. And again, once you have your data entered, we're going to begin analysis. There is our picture. So down here, we want the regression model. Calculate other regression model. We want the quadratic model. And I'll click that button, and here we go. So let me take a picture of that, and I'll copy it into our slides. Well, let me get out of present mode real fast. So paste it. And then we'll talk about how it presents it and what I want you to do. So paste maybe. There we go. I'll make it a little bit bigger. So again, if you notice, right, they did not put the x squared first. They put it last. So when you write this down, I want you to put y hat. Now you're going to see in Edge Elastic, you can't enter y hat. So I want you to put y hat, just like that. equals, okay? But this is really the symbol y hat, okay? So this is what you'll put in edge elastic, y hat equals, and again, I want this part first, 0.043x squared plus 0.33x, and then minus 2.294. And that's your quadratic model right there, okay? Oh, sorry. Okay, next, sketch the scatter plot along with the quadratic model. So this is pretty simple. Let's just go away from here. I'm going to erase that model real fast. So when we come back to our stats applet, now you will see there are two graphs. One says speed and distance, one says speed and residual. So this is the residual plot. We don't want that. We want the scatter plot, right? And notice that when you click calculate the regression, it puts the model through the data. So that's what I want, right? So I'm just going to screenshot this or snip this, and I'll also paste it into my notes somewhere. There we go. And again, it just goes somewhere so I can see that you know how to use the stats applet. Okay. So that's the scatter plot. And then there's one more part to this question here, part C. So this is the same paragraph as before. Calculate and interpret the residual for the last observation in the table. So the last observation is this one right here, 48 miles per hour and a 110.33 stopping distance. Okay. So what we're going to do is we're going to compare. So 48 miles per hour and 110.33 feet. Remember, this is your x, y, the actual y. So we're going to use our quadratic model to get y hat, the predicted value. Okay. So I'm going to do this in my handheld no, I'll do it up here. Okay, just so you can see. So let me screenshot let me take a picture of the equation. So the equation is there. Okay. All right, so I got it. So if I go to Desmos graphing calculator, let me get rid of this. Okay, so our equation is 0.043. I'll use parentheses. And then my x value again is the x of the last observation. That's 48. So 48, close parentheses, that's squared, plus 0.33 times 48 minus 2.294. And because it ends, we'll go ahead and put that whole thing. Just be careful of how I tell you to round. So 112.618. So that is your y hat value. So your y hat, so again, we're comparing it to this data point where this is your y value. So my y hat value is, oh, I forgot. Don't go away, please. 112.618. Oh, went away. 112.618. Let me write that down first. So my y hat value is 112.618, and that would be feet. And this is my y value. So to find the residual, you always take the actual minus the predicted. Y is 110.33 minus y hat is 112.618. And I'll just use a handheld calculator for that. So 110.33 minus 112.618, and I get negative 2.288 feet. So that's your residual, and now we need to interpret that residual. So when we interpret the residual, here's the kind of form we're going to use. So we're going to say what we're measuring, the braking distance. So the braking distance, that's what our y value is, was 2.288 feet. Now notice I did not include the minus sign because now I will use that as a word, right? So because it was minus, that means that the actual was this much less than the predicted, less than expected. And then you finish it with based on the quadratic model with x equals speed, and that was in miles per hour. Okay, so this is your interpretation right here. The braking distance was 2.288 feet less than expected based on the quadratic model with x equals speed in miles per hour. Great. Okay, this was objective one. Objective two is very similar. It just deals with exponentials. Coming in a second.